number 161 in your classwork for quadratic functions asks if we have a function f of x equals ax squared, where a is greater than 0, and we have another function g of x is mx plus b, so this is just a linear equation, and both of those constants are greater than 0, or less than 0, sorry. And the equation f of x equals g of x has n distinct real solutions. So what are the possible values of n? Justify your answer. So when we have a graph, I think it'll be easiest to visualize. If we have an a of x squared, so this means that the vertex is going to sit on the origin 0, 0, and we're going to have x squared scaled by a factor of a. So I won't put in dash marks to like label what these values of x are, but that is the general look of the curve. So this is the curve of a of x squared. And then if we have a g of x is mx plus b, but m and b must be less than 0. So this means that my y-intercept has to be below this 0. So it can be here, 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 anywhere below the x-axis. And my slope is negative. So my slope could be like this. My slope could be maybe a little steeper. Maybe it'll touch. Maybe it can be tangent to my quadratic equation, or it might actually go through 2 points. But it will never be able to sit on the x-axis because our b must be less than 0. So we have n distinct real solutions. So looking at this first line that I drew, and the second, and this one's third. So this first one doesn't even have a solution with the quadratic equation. They don't touch. There's always this separation between them. There's always this amount of space in between, and they will never have a solution. So we have n distinct solutions, which for now we have 1. We also have another solution with this line that we drew at 2. So this touches the parabola only once. So that is also another solution to this problem. And then we have the line at going, so my line at 3, going and touching the parabola at 2 distinct places. So when we have n distinct real solutions, we could have possible values of n of 0, we could have n equals 1, and we could have n equals 2, representing it not passing or not touching the parabola. So this would be case 1. This would be touching the parabola just at a tangent point, so this would be case 2. And when we have 2 solutions, this would be case 3, when it passes through the parabola twice.